Hello, everyone. This is Alex, and welcome to the mathleague.org YouTube channel. We'll be talking about sprint problem number 24 from the April 2021 high school test 12107. Okay, so here we're dealing with a really thin triangle with a really large vertex angle, right? It's practically a straight line. So well, thankfully it's not. We'll just pretend it's any ordinary triangle, right? That way we don't have to work with these sort of messy lines, and it just makes everything so much easier to see, right? So we'll just kind of draw it to be, obtuse, but not so much so that we can't draw the lines. There we go. And so we construct its centroid. Remember, that's the average of the coordinates of the triangle, but more vigorously, it's also the intersection of the medians, which are, in other words, the line segments from each vertex of the triangle that go to the midpoint of the opposite side, right? So, for example, this is a median because it's going from, let's call it vertex A down to the midpoint of BC, and the median from B goes from B to the midpoint of AC, and the median from C goes from C to the midpoint of BA, right? So if we were to like superimpose this on a coordinate grid, that would be the same thing as saying that the centroid is at the mean of the coordinates of the vertices. Great. So what do we do now? Let's read the rest of the problem. It says lines BG and CG intersect AC and AB at D and E respectively, and we want to find the ratio of the area of triangle DGE to the area of triangle ABC. Now, I hear you thinking to yourself, but surely that's impossible to find the area when the angle measures are 179.99 and 0.005. I don't know how to take the sines from those in order to use the law of sines. Well, the good news is we don't have to. And in fact, we really shouldn't try. So if we just remember one key fact about centroids, is that they always split the medians into a 2-to-1 ratio. So in particular, this line segment is going to be twice the length of this one. Awesome. So basically the medians are halfway up the line segments BA and CA, right? These are the midpoints of BA and CA, which we're going to call D and E according to the problem statements, where D is the intersection with AC. So that's should be on the other side. Yeah, this is point G, and D is the intersection of BG with AC, and same for E with BA and CG, right? So DE then is half the length of the base BC. So DE is 1/2 times BC. And what about its height, its altitude, the altitude of triangle DGE? Maybe we can use the fact that the centroid splits the median from A to the midpoint of BC. This altitude, it's also an altitude. It also splits this line segment into a 2-to-1 ratio, right? And therefore, that the part of the height that lies below point G is 1/3 of the entire altitude, and so AG is 2/3 of that height. If the line DE lies halfway above the triangle, then the remaining part of the height has to be from G to this midpoint of DE. That has to be 1/6 the height from A. And now we just multiply those together. So if we call, say, M is the midpoint of DE, then GM is 1/6 of altitude from A. And so we just multiply the two together, right? There's no need to divide by 2 because they're just ratios. So 1/2 times 1/6 equals 1/12, and we're done.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.